Hello, in this lesson we're looking at powers of numbers and especially at squares and cubes. Now most of this is number work and you'll find links to factors and multiples along the way, but I think it's worth beginning by reminding you where the names come from. Now here's a square which I've divided up into smaller unit squares. There are 1, 2, 3 squares along each edge and there are 9 squares in total. So this shows us that 9 equals 3 times 3. And you know that we have a special notation for this. 3 times 3 is 3 squared, or 3 to the power 2. Now we can do this for any number. Here we've got 16 squares, or 4 times 4. So 16 squares arranged as 4 times 4, which we can write as 4 squared. Now the name square comes from the fact that these little squares are arranged as one big square. If I had 16 small squares, I could arrange them as a pattern in many ways. I could have a long strip of 16 squares, so 16 squares long and 1 square wide, or 2 rows of 8 squares. But 16 is a square number because one of the ways I could arrange them is as a 4 by 4 square, and 9 is a square number too. In fact, apart from a 1 by 9 strip, a 3 by 3 square is the only way to arrange 9 squares, and that's because 3 is a prime number, as you know, and 4 is not. Now you can square any number, even a rather special case. If you want to, you can think of 1 itself as 1 squared. Well, that's where the name comes from. Let's go and see what we can discover about square numbers. Here are the squares of numbers from 1 up to 12. Now these are numbers that it's good to be able to recognise on sight. Squaring is an arithmetic operation. It's the operation that takes 7 to 49, for example. So it may have an inverse, an operation that takes you from 49 back to 7, an operation that undoes the effects of squaring. Now that operation is called taking the square root. So 7 squared is 49. The square root of 49 is 7. Now we have a special way of writing this. We use this square root sign. It's a bit like a tick mark. Now it's all very well knowing these 12 squares and of course the corresponding square roots, but what can you do if you get a problem like this? What's the square root of 900? Well, the key to this is to split the 900 up into factors, simpler ones that we can recognise square roots in, and this process is called factorising. And this time, the obvious way of factorising is the one we need. We'll factor 900 into 9 times 100. So, when we want the square root of 900, because of the way the square rooting works, we can take the square roots of the factors separately. And both these roots are in our list of memorable squares. The square root of 9 is 3. The square root of 100 is 10. So the square root of 900 is 3 times 10, or 30. The square root of 900 is 30. Well, perhaps 900 was a bit too easy. Let me show you another problem and how your knowledge of factors and multiples can help. What is the square root of 196? Factorising will help, but what are the factors? Well, let's just take a minute to run through the possible factors. Now, the last digit of 196 is even, so 2 is a factor. How about 3? Is that a factor of 196? Well, the sum of the digits is 1 plus 9 is 10, plus 6 is 16, and that's not divisible by 3. And that means 196 is not divisible by 3. How about 4? Well, let's look at the last two digits. 96. Does 96 divide by 4? Quick mental maths. 96, half of that is 48, half of 48 is 24. 24 divides by 4. So 196 does divide by 4. What about 5? Well, 196 doesn't end in a 5 or a 0. So 196 is not divisible by 5. How about 6? Well, to test for divisibility by 6 means you have to test for 2 and 3 separately, and 196 has already failed the divisible by 3 test, which means it's not divisible by 6. So, what possible factors do we have so far? Well, just 2 and 4. We could go on, but in fact, we've done enough already. I'll factorise 196 using the information we already have. Which of our 2 possible factors should we use, 2 or 4? Well, we need 4 for 2 reasons. Firstly, using 4 as a factor will make the other factor smaller. And secondly, 4 is a square number, and that's what we're looking for. So I'll factorise 196 as 4 times something. What's the other factor? I can just about do this mentally, but it wouldn't matter if you needed to use a calculator. 196, 4s into 19 go 4, that would be 16 with 3 remaining, and then 4s into 36 go 9, so the other factor is 49, and that's nice because that's another square number. So the square root of 196 is the square root of 4 times the square root of 49. The square root of 4 is 2, the square root of 49 is 7. Multiply those together and we get 14, so the square root of 196 is 14. Now, I said that it wouldn't matter if you used a calculator to help in the factorising, but let's be realistic. Calculators have a button that takes square roots for you. All you need to do is type in 196 and press the square root button, and out will pop 14. So you'd really only be doing this square rooting if the question said you couldn't use a calculator. But now I want to look at cubes. Just as the name square for square numbers came from thinking about geometric squares, so does the name for the cube numbers come from real solid cubes. This cube here is divided into 4 units along each edge. That means that there are 4 times 4 times 4 smaller cubes in this large one, and that works out to 64 little cubes. Well, 64 is a cube number, and we write it as a power, and that's 4 cubed. Once again, you can do this with any number. Here's a 5 by 5 by 5 cube, and that has 125 smaller cubes in it, and we write that 5 cubed. Okay, that's where we're coming from. Let's see where we're going. Here are the cubes of the numbers from 1 to 10. This time there are fewer cubes that you ought to know as number facts, just those for the numbers from 1 to 5, and the rather useful 10 cubed, which is 1000. Everything works for cubes pretty much the same as it did for squares. The inverse of cubing a number is called taking the cube root. Because 4 cubed is 64, the cube root of 64 is 4, and we write that using a symbol that's very similar to the one for square root, but has this little 3 up here to show that although we are taking roots, this time it's the cube root we're interested in. And you can find cube roots by factorising, just as you did for square roots. So if I want the cube root of 216, I factorise it. And this time it comes out as 8 times 27, which is very nice because both of those are on our list of cubes to remember. So the cube root of 216 is the cube root of 8 multiplied by the cube root of 27. And that's 2 multiplied by 3. So the cube root of 216 is 2 times 3, which is 6. Now, to finish off, before you go and practice rooting around with squares and cubes, one last thing, and it's a bit of a warning really. We're back with squares now. If I want to calculate 3 squared, I multiply 3 by 3, and of course the answer's 9. But that's not the only way of getting 9 from multiplying a number by itself, because negative 3 times negative 3 is also 9. And that means that 9 actually has 2 square roots, positive 3 and negative 3, and that's true for all the numbers that have square roots. But there's something else here too. If I multiply 2 positive numbers together, I get a positive number. And if I multiply a negative number by another negative number, then I'll get a positive number again. So I could never get a negative number from multiplying either positive numbers or negative numbers by themselves, and that means negative numbers can't have square roots, but positive numbers do. So good luck with the exercises, and I'll see you in the next lesson.